Facebook page about a research that we did with a student here at the university, and the whole research was kind of funny. It was kind of interesting actually, because what he did was we printed, milled, and just did a regular acrylic basis. We did several rectangles just to see how the materials behave. But this was not about the strength. Most people, when they evaluate these kind of things, they test the strength, which is really important as well. But in dentures, one of the most important factors is how dentures retain. And it's a multifactorial thing, but one of the things that will affect the most the retention of these dentures is cohesion. So cohesion is basically how these materials integrate with water. In this case, it could be saliva as well, and how they will retain in those watery conditions like the mouth, right? So we printed, milled, and just created some specimens, and we tested them because, of course, our control group was going to be the traditional acrylic, the traditional denture acrylic. And what happens is there is a special machine which I didn't have access to because I'm working with some people that are PhD in biomaterials in all these kind of research projects. And they have a special machine which is a machine that can inject liquid. It has like a little needle, so you put something in there, and that needle is gonna put on top of these specimens a specific amount of saliva. So the student that was in charge of the research, what he did was he spit on a tube, and that tube was put in the machine, and that little needle was going to put in a specific amount of saliva. So there was a high resolution camera that was going to be able to see how this material was going to be wetted. So there is a drop that you put on top of the material, and of course if that drop spreads, the material is going to be hydrophilic, and if that material is hydrophobic, then when you put the drop is going to be it's not going to spread. It's going to stay more like on a drop on top of the material. It's going to be more like a circle. So of course there's ways to measure it, because what we need from those research are numbers. So the machine, once it captures at a specific distance and at a specific time, when it injects the material, it captures the drop. We can also measure the angulation of the drop, and those were the numbers that we can be based on to determine if the material is hydrophobic or hydrophilic. And there is also resistance to it. So once the needle injects the saliva, then it will basically suck again that saliva, and we can measure the resistance. In this case, all the samples were evaluated with saliva, and the same saliva of one person who was the student. So we measure it, and if you see in that picture that I posted in Facebook, the results are at the bottom, and you're gonna be able to see how the materials behave. So of course our standard is the traditional acrylic, and then for some reason the printed specimens didn't behave that well versus the milled PMMA, which was actually better than the material. And I was seeing this in my clinical practice when I'm doing digital dentures. I usually don't print the finals. I still mill the finals, but I did that because of the strength. Clinically I can see the strength of the PMMA that is milled is way better than the printed resins. But at the same time, when I was delivering interim dentures, I was noticing that it wasn't that awesome, the retention, but I thought it was because everything was healing and everything was changing, which is part of the deal too. But it was also cohesion, and I never thought about it. So there are some solutions that can be done in order to prevent this, but at this point of time, it was kind of interesting to see that scientifically, those are the results that we're having. So again, people are focusing too much on the technical portion. We love the technical portion, how to make things. Just teach me how to design it, how to manufacture it. Doesn't really matter how the material behaves, but all the research, of course, the tech is going too quick, and all the research cannot be speed up to the way that it can catch with all the different materials that are, being released, and it's just crazy. But at least for the people that are giving lectures and that call themselves experts, what we really need to do is to put some attention to those properties of the materials, because so many different resins are coming, so many different things are going to be released in the next couple of months, and I think it's really important. It's really important to make sure that the materials that we're using those materials responsibly, and that we know how materials behave. Is kind of weird, because of course I'm always trying to be on the forefront, but at the same time I have this irony of being a clinician, and of course I have to be responsible with my patients, and I need to offer them something that is gonna last a long time, that is gonna be a good quality treatment for them. So the irony of, like, okay, well, maybe I have the luxury, of course, that I can test these materials in an academic environment, and then once I know how they sort of behave, then I can start applying that clinically. But for the real clinicians, for the ones that are practicing every single day without doing any research, or for the lab technicians, it's just a call to responsibility in terms of, like, we really need to know, and sometimes we really need to slow down and make sure that we're not screwing that up. So anyway, this was just a video to share that experience with all of you guys. There are so many things that are coming, accuracy studies, different things that I would like to share with you, but I'll probably share those